everyone, how's it going? It's Liz from Dfinity Foundation, and welcome to Community Conversations. So this is an opportunity for you, the community, to hear from contributors within the internet computer ecosystem, as well as ask them questions live. So today we have SDK team lead Kyle Peacock going through how you can host a static multi-page website on the internet computer using the certified asset canister, along with any images and other static assets you may need. This talk is targeted at beginners, so feel free to ask away anytime. All right, Kyle, feel free to take it away.
All right, hello everyone. Nice to be back doing another community conversation. Let's get it kicked off. The format of this is going to be, I'm going to walk you through, first of all, our new documentation on the quick start for the Dfinity docs on hosting a static website. That should only take like maybe 15 minutes or so, at which point I want to open it up for an initial round of Q&A, and then we can decide where that's going to take us. I've got a number of follow-up topics that we can go through, but let's get this started with hosting a static website on the internet computer. So first of all, I'll bump this up one tick for everyone. So first of all, before you get started with this, we also have another guide on how to claim free cycles and get set up with a cycles wallet. That's going to be a necessary prerequisite for getting your website hosted, because on the internet computer, when you are hosting assets, you're going to be doing that through a canister. It's a custom canister, one that has this special method for HTTP request handling that it exposes, and then that is passed through the boundary nodes. But you need to have the ability to create canisters and manage them on the internet computer before this is going to work. So if you are following along, you would start off by doing the faucet quick start and setting that up with your SDK, so the dfx tool. Great, so for this project, the basic format is we're going to create a static website, just like you would for any traditional static hosting. So if you have a background, like there are a lot of classics, but like something that you would drop into like the public directory of Nginx, you would host this with like Node.js or Python or really any number of tools, where you have static files of HTML linking out to JavaScript, CSS, assets, and whatever else you want. It should be very, very familiar. It's static hosting, and we've done a pretty decent job of simplifying the configuration here. So in the startup example, we start with index.html with a very boilerplate setup here. So you can see that we've got a link to style.css because it will be adjacent to that. That will be able to link directly as you'd expect. Same goes for an anchor tag, the ahref linking out to page 2, and script.js loading in some JavaScript. Page 2 can link back to the index, also include styles. And we have a very simple script and some CSS. This is showing how you can do some dynamically loaded content by taking an existing tag here, this dynamic content tag, and interacting with that, putting some content into it. And style.css is going to, select the first paragraph and change the color. Pretty straightforward stuff. Now, this is the part where we're talking about the internet computer specifically. So from the structure that we've set up here, in this project, it'll look like dfx.json sitting in the root directory, and then some folder that we've named assets here where we've got all of the static assets that we want to link to. When we configure dfx.json, we start with the list of canisters, or it's a map of them. We'll name ours website, but you can name it anything. So if you have multiple asset canisters, or if you also have backend canisters that you'll want to include, you'll be able to do that just by naming them whatever you want, and you can really have any number of them all configured in the same dfx.json. The type assets now is a special sort of like a reserved type that we provide with dfx, which is going to give you the certified asset canister, which hosts all of your files on the internet computer, and will also come along with compatibility for the service worker, which gives you certified assets on ic0.app. We can talk about the distinction between normal assets and certified assets a bit later in the talk. Then finally, this last category here is the source, which will be a list of folders that you would like to include and have uploaded into the asset canister. So we'll be uploading and pulling from the assets directory that's here just inside of the folder that we're in. So now that that configuration is in place, all that you need to do to take these static files, this multi-page website, and deploy it to the internet computer on the mainnet is to run this command, dfx deploy, specifying network IC. If you don't specify network, dfx is going to try and deploy this for local development. But if you specify network IC, that will tell it to go to the mainnet. And it will, if you haven't deployed it before, some of the output here is skipped, but it will essentially go through your Cycles wallet, instruct the Cycles wallet to talk to the management canister of the internet computer, create a new canister for as many canisters are as specified in dfx.json. And then once you have, pardon me, once you've uploaded your canister, the WebAssembly module to run on the canister, then we have a follow-up script that will upload all of the files in your asset directory, and then wrap up and complete the process. And as you can see here, we're automatically gzipping your assets for improved performance, as well as if you have large assets, like some large images or videos, we'll be able to chunk those as well automatically and upload those to the asset canister. And that's important for some constraints around the maximum message size that can come in and out of WebAssembly. So to review, the command is simply dfx deploy network IC. All of the assets will get uploaded. And then to go see that live website, you can check the canister ID of the website, which will look like something like this here, where you've got these hyphen separated strings of characters. And if you go to canister ID, pasting in that canister ID, .ic0.app, you'll then be able to load up your website and interact with it. And if we pull that up here, this is what this looks like running live on the internet computer right now. All right, so that is the core of the demo. This is how you can host a static website on the internet computer. So yeah, let's look at Q&A. see what we're about right now. So 2 questions from Fawaz. Pardon if I'm pronouncing that wrong. Do we have an academy for teaching about their programming language? I think that we should have multiple dives into community conversations and just other educational materials around Motoko, which is our programming language. Although we do want to note, we do support Rust as well for Canister development. And the second question, why do we have this like long name? Why can't we have like a simple regular domain name? So yeah, let's talk about domain names. What we have right here is a domain ic0.app, which is provided by the boundary nodes. So it is registered to a limited set of boundary nodes, which are able to handle messages over HTTP and turn those into queries that are going to serve back content from the internet computer, so the actual HTTP responses. There are a couple details worth talking about as part of the bigger picture here. So if we look at ic0.app, and if we were to view page source and hard refresh to clear the cache, you can see that what we actually deliver directly from the boundary nodes at ic0.app is something you may have seen for a brief moment, which was this installing the internet computer service worker. So there's a brief loading page where that runs. And in that moment, we actually are loading up a service worker, which is then going to handle all subsequent requests to pull data from the internet computer. So all of the other assets are pulled through the service worker. And the service worker is actually doing some validation of the certificates of all of the assets that you want to pull. That is being managed by a special header that the certified asset canister, which you can take a look at here, Dfinity/certified assets. So that sends a special header along, which the service worker is able to verify, which allows us to do queries that are fully certified using the chain key cryptography that we use for our consensus model. So you can't arrive at the certificate without having gone through consensus, but we can still serve that as a single query for the highly performant web experiences that you'd expect. So that is the work that is happening with the current boundary nodes at ic0.app. So because we're providing that for you, that's kind of like the way that you can talk to the internet computer. In order to have another domain that's able to also talk to the internet computer and deliver the websites, you need to configure something that's going to do the same work of translating the HTTP request into a query to the internet computer for the canister that you're trying to talk to, and then pass that along and get back the information. So that is what we have right now, but it's not to say that you can't do this with another method. So something that you could do today, if you wanted to, would be to go into Cloudflare and implement your own logic of translating the HTTP requests into queries to the internet computer, and then run your own domain and be able to send those requests from foo.com over to your specific canister. The main reason that we don't and haven't like officially endorsed or written that up yet is, of course, it takes away from some of the decentralization aspect. If you're just going to go through some Web 2.0 domain name service, but domain name is a bit of a sticking point. It's pretty hard to do a truly decentralized DNS system because there are some pretty hard constraints that call for that. Anyway, we do hope to at some point offer a solution where you can go into something Dfinity provided and customize your own domain name. But that has been pretty challenging from a technological standpoint. And someone else may even beat us to the punch with that. So the technique of using your own domain name is actually what happens if you're going through Fleek. Yeah, so if you go through Fleek and you go through their internet computer hosting flow, they are going to do for you everything which I've just said. They're going to host you on an asset canister. They're going to set up that domain name if you configure that for them. And they're going to use Cloudflare, I'm pretty sure it's Cloudflare, to do the pass through to the internet computer for your domain name. All right, so that's my answer for where we're at with domain names. Next, I have a question from Austin. What does it mean to say that a canister is certified? So yeah, the certified assets is something that we should not expect anyone outside of the organization to understand off the bat. What it means is that we have basically a cryptographic strategy for producing a certificate that we're going to do that represents the like the state of that asset. It's something where we use like a Merkle tree with like substitutions and hashes. It's relatively complicated, and it's honestly not my strongest domain expertise. But we do produce a certificate. Let me see if I can find this here in this document. And when we are passing the asset along, we pass a specific header into the HTTP request that gets passed along with the asset, which we then have code at the other end of the equation with the service worker, which you can see in our agent.js repository. Service worker certification. That's where it's registered. Here in the validation. And we pass it through our certificate package from the JavaScript agent. And we go through this whole process of looking through the tree, the Merkle tree, and validating it before we then accept it as a certified asset. So it's not like a concept that's really part of the broad Web3 picture yet. It's an innovation that Dfinity has really pushed forward, and huge props to Roman, the tech lead who has really pushed forward this technology, as well as like other community members like Joachim and lots of other amazing folks that we have in-house that, or have in-house and have worked with us at Dfinity to make this possible. So it's just it is our path forward for saying that this asset it has gone through a consensus process. You can trust it, even though you don't necessarily trust the individual node that may be delivering the asset to you. So that's how we can have this decentralized network where we don't have to have trust of any particular node in order to trust the whole network and still be able to serve assets and, potentially crucial JavaScript and all of these other things as people are moving tokens around and doing all kinds of secure things and with the level of privacy that you want on the internet. Let's see. Once deployed, is it possible to take a deployed canister down? That is going to be very possible. Once you are in dfx, if you control that canister, you can simply do dfx canister delete. So that's another command on the canister route. So you would do dfx deploy. When you're done with the canister, you would do dfx canister delete, and it will refund the cycles balance that's remaining on the canister back to your cycles wallet. And a related question of, can you see a list of all the canisters you've deployed? You can see that on the cycles wallet. So if I go into my terminal, and I need to do a new share of the whole desktop here, or this right here. All right, so if I say cd, actually I don't need to do anything, dfx, identity, network, IC, get wallet. So this is configured to be the wallet that I have for the Internet computer. Back to Chrome. And if I go to here, .raw.ic0.app, I actually have a UI for the Cycles wallet that I can log into and take a look at canisters I've created. And I do apologize a bit for the state of this UI. It's gone a little under-maintained. And yeah. So the list isn't super accurate, but yeah, you can see a list of canisters here, and we have some upcoming work to improve this UI a little bit. You also have the ability to send cycles directly out of your balance and create new canisters directly. So yeah, fun fact, we haven't really advertised the fact that this UI even exists that much, but it does, and it's built into the Cycles wallet that you get. Let's see. So I've got a question from Tarek. What should we do if we have a lot of assets and when we try to upload, we get an error for exceeding cycles per message limit? This is something that basically is just something that my team, the SDK team, needs to fix. We have actual active work on this ongoing right now. So we hope to have a better answer for, honestly, these sorts of things should just work, right? We should be able to manage that. We should manage retries for errors. It should just work when you try and deploy. So In the meantime, if you are blocked, what I have done in the past is to try and like step by step dfx like deploy by adding in some assets like one at a time, basically for really large ones, until that they complete the deploy process. DFX knows to not bother to retry assets that are already loaded up onto the canister. So that caching can kind of be like a way to cheat through it and get something like a lot of assets deployed all at once, if that's a problem for you right now. So sorry about that, but we are trying to streamline, smooth out that process a bit. James asks, are there plans to implement platform level DOS protection or denial of service? Yes. Not only are there plans, but there's a decent amount of effort that's already gone into this. Now, the boundary nodes is not my team, but I do sort of follow along to what's going on over there. And we do have a certain amount of like rate limiting. So a great example would be if you look at like the IC punks drop, where everyone was trying to claim all 10,000 IC punks on the network on a single canister all at once. What happened was the boundary nodes were able to handle all of the requests that were coming in. The network slowed down considerably for that subnet. But what ended up happening was even though the responsiveness of like getting through was coming in, what people were getting back were these error messages from the rate restrictions. And the boundary nodes were successfully able to prevent the network from crashing from, infinite throughput. Although there was a sort of degraded experience for the people who were trying to access the drop at the time. So the design of it is designed around protecting against DOS attacks. And we've since done some better tuning around caching as well. So gets are automatically, I believe, cached across the board for 1 second for queries. And yeah, you can also, I believe if you go into your asset canister, and if you were to configure the headers for the cache management, that the boundary nodes would respect those as well. But we don't really offer a great level of configuration on the asset canister. Like it would be, I think a good project would be going into the dfx.json config and being able to fully customize the way that the asset canister behaves, and really investing a considerable amount more in that customization so that it behaves more like what you would expect out of maybe like an Amazon style dashboard, or if you work with Terraform, the sort of more enterprise style features, I think we should be trying to lean into a bit more. So that's where it's at. Like, it's an ongoing process. I think one of the strongest issues we have with the current boundary node structuring is that we kind of are applying rules across the board. And I would personally love for us to go into a direction where people can pick their own boundary node provider, can do a lot more customization, and tune things so that the settings are more in the hands of the individual developer, and we're not trying to just create rules that will be universally applicable, because I know that people have a lot of different use cases and we can't predict everything. I see in chat, there's a question from Psychot of what is the difference between an update call and certified results if both rely on consensus results from majority nodes of the subnet? Great question. So an update call, you can use that in two ways. And it is fundamentally about whether consensus is achieved for a certain result. So if you have state that you want to update in your canister, then that is going to, across the board, always have to be an update call. And that's why we named it an update call. So if you're modifying the state of your canister with a call, that has to be an update and go through consensus so that all of the canisters have reached the same state. And that's going to take you 2 to 4 seconds typically. Now, with certified results, the reason that we're able to process that as a query is because we want to, is because we've essentially done the consensus up front. So at the time that the asset is loaded, we put it through consensus, and we use that consensus round to create the Merkle tree that we then send as the certified header. And it can only be brought to a complete round of consensus in order to form that, that tree representing the state of all of the canisters if they have gone through consensus. So a single canister wouldn't be able to produce a falsified representation of the state of those canisters and then pass that along in the header. So by doing the work upfront, we can sort of like front load that and then get the performance on the back end of a really fast query, like 20 milliseconds, as opposed to going through 2 to 4 seconds of consensus for that query. So it's a really, really helpful scheme for the sort of web performance that we're able to offer on the internet computer while still being decentralized and, you know, having this lack of trust of an individual node provider. Worth mentioning, we don't have like a great API for this right now, but it is possible to structure any query as an update call in order to like require the replica to go through consensus. That is a feature that we have. So if you have like, you know, you're in your agent.js and you want to, you have some very, very important data that you need to make sure has gone through consensus and that you're getting the latest state of all your canisters, you can simply omit the query from the IDL markup. And then it's possible to just have that go through consensus and you get your data back. So little known feature, but one that's occasionally pretty useful. All the things I am demonstrating are written in technical documentation for ICP, or is it found in the forum? Yeah, so like, frankly, documentation exists, and we have some work to do to try and make sure that it's consolidated. Like if I just type certified, I guess the top hit that we get here is certified data. And this is something out of the Motoko library, which isn't even exactly what we're talking about with like a certified variable or a certified asset. So the smartcontracts.org doesn't necessarily contain all of the knowledge. And so there's more work to do, especially on smartcontracts.org. So the forums are a good place. I'm pretty sure you would be able to find pretty much everything that I've described in the forums. But it's also distributed throughout recordings of some of these community conversations, Medium posts, and a variety of other areas. So definitely check the forums. But that's not to omit our own responsibility in this. We have work to do in making sure that all of this is not only documented and publicly visible, but that it's also presented in an approachable way. It certainly wasn't easy for me to acquire all of the understanding of the picture of the IC I have. And I recognize that there are gaps in how we communicate it. But we do also want to be deliberate as we, send things over, because if we took all of the knowledge that we have internally and just dumped it out, that wouldn't be particularly useful to a lot of people either, because the presentation matters an awful lot. And let's see, we got another question from Austin. Is it possible to run your own boundary node? Not current. Well, you could run something equivalent to a boundary node, like I was saying, with to like some sort of, literally, you could run your own server for that. We have a proxy. Where does that even live these days? I think it's CDKRS. Oh, I guess we've moved it. I need to look up where we moved the proxy to. We do have a proxy that we build that anyone can run. It's what we actually use in dfx. And you could run that like it's a little Rust server that proxies the requests. You could do the same thing in Node using agent.js. So you could run effectively your own boundary node. But you'd still want to go through the main boundary node for the API, for example, at ic0.app. And although I would like to see a sort of distribution of the boundary nodes, there's some talk about that on the forum, and we'll see where that conversation goes. But I like where people's heads are at with that. Let's see. Tarek, Mustafa, would there be a talk around agent.js? Totally, I can probably do that in 2022. I'm like the main maintainer of agent.js right now. So that would be me. And part of the reason I haven't done just like a talk on it is it's a really big package and there's relatively little documentation. So I guess I'm feeling the pressure of this giant code base that needs to like be documented in the first place. So I would probably write the documentation first and get that in front of people. And then do a talk, sort of like what I did with my sort of presentation of static websites just now. And also, I can look at the chat, but if anyone doesn't mind, it's easier for me to go through the Q&A session. Let's see. So question from Austin. Oh, wait, no. Another question from James. What are some important design considerations for dApps targeting SNS? SNS in this case refers to the service network system. And that's our plan for having basically like DAOs or sort of a tokenized governance for a project. I don't think I can offer too much on how to design your app for that at this point, because there's so much that still is being finalized and worked on for the SNS. So ideally, it should be something that you can slot into any basic application and find some way to incorporate. Yeah, I don't think that we have like a list of design constraints that we have ready to offer anyone for that. Let's see. Question from Psychot. Do I envision any SSR frameworks working on canisters? What wouldn't be needed to be implemented in current frameworks like Next.js, Svelte, etc.? I totally imagine SSR coming into play in some degree or another. Getting it to work with a full JavaScript implementation is probably a pretty heavy ask, right? There is potential for that if Jordan Last's project for running JavaScript on canisters, has a lot of success at Azel. I'd like to see, obviously, something like a full Next.js kind of experience would be really cool to have on the internet computer. In the meantime, I think that a more pragmatic step would be getting some sort of templating framework in Motoko, or even finding one in Rust that already exists and starting with that. The sort of progression is, before you do like full server-side rendering of the JavaScript, the very least you can do is start to insert some individual blocks, some static HTML, or script tags that have keys that are passed from the backend for anti-botting purposes and tokens and all of those sort of classic strategies for security purposes. So if you actually take a look at the Internet Identity Framework, we do some of that. There is a token for registration that needs to be passed by the actual canister, and they inject that into the HTML that they deliver to the front end. So the start of that is already very possible. So I think that we would get something like that, where you just are templating straight HTML rather than sort of like executing server-side JavaScript and rendering that into something. It would stick to just the one language. I have a question from Trevor. Can we deploy standard databases with ICP, or would data have to be written to the blockchain? And this is a beginner-friendly talk, so no need to apologize for that. It is technically possible to deploy a standard database to the internet computer. We've seen someone actually take just a slightly modified version of what was that? It was SQLite, and just ran that on the internet computer. Basically, the principle is anything that can go and run inside of a WebAssembly context can be run on the internet computer. And for something like SQLite, which I think is C-based, someone was able to compile that, get the right headers and the interfaces in place, and run that. Now, it is different from a lot of existing applications may not be usable for that, because we don't have like a full file system. We're not based on Linux under the hood. We just have basically this WebAssembly environment and direct access to storage and memory. So your entire canister is basically held in RAM on the internet computer. So the way that you structure memory pointers and handle them are going to be a little bit different. So a lot of like out of the box offerings may not be able to run perfectly on the internet computer, but you may or may not need to reach for those. One of the interesting opportunities that you have on the internet computer is that you can just like keep your information stored stably on a canister. It can be in the same canister as your core application logic. And that's not really a problem based on the architecture we have. At certain points of scaling, people may have strategies for that. And there are some problems that you get that there are solutions for in traditional databases, like sharding and some of these auto-scaling attributes that aren't really solved on the internet computer yet. But we've got some really bright minds that are working on it, and some people who are already uploading just truly mind-boggling amounts of data to the internet computer and running applications with that. So you could use SQLite, that's already available. But I would say just like for the meantime, if you're getting started, just start with like the Motoko model of using stable memory, or going into Rust and handling some pretty straightforward store a variable and handle the pre-upgrade and post-upgrade hooks for it. Migrating existing databases to the internet computer. I mean, it's really just like, we have an existing project for like an interface of someone who's ported a GraphQL interface to the internet computer. But I don't think anyone is really, so far, we don't have anyone who has the passion of, I want every style of database to just exist on the internet computer, and has ported them over. I think that maybe a tool for taking an existing database and migrating all of the data over would be nice, but it's tricky because you have to implement the same kind of joins and queries and all of the functionality more or less from scratch. And those are pretty evolved and sophisticated bits of software for the most part. So it's not a light task, and I don't think people are typically going to go do that on their own without funding. And certainly no one is like actively working on that in-house at Dfinity right now.
Cool. Any more questions from people here? Let's see. See that Psych had sent along a link. Awesome. Kyle, did you get to this last question from Austin yet? Or?
Question from Austin. Where did that go? How many companies or orgs are participating in building out infrastructure for ICP? Liz, you might actually know better than I would.
That's amazing. You mean like, Austin, do you mean like from like an enterprise perspective, or just like general like developer tooling? So I can answer. I can answer both. So I think from an enterprise perspective, just generally speaking across all chains, it is still quite early. I will say that from like an infrastructure perspective, a little bit of an alpha week, but I am planning a global hackathon for next year with different categories. And one of the categories will be around tooling and infrastructure. So if you are a developer who is in need of a particular tool that doesn't exist yet, you should definitely participate for the chance to win some prizes. Great. So I think that just about brings us to the end, unless anyone has any last minute questions. So big shout out to Kyle for your efforts and answering all the questions, and also for your demo. Thank you for everyone for being such a lively audience. And oh, James added one more question. James says, I see.
Recommendation for backing up and restoring canister data in case of data loss. So in the meantime, like today, we recommend that you create methods for doing that and gate them to controllers of the application. So this is a pattern that places like Discover and a bunch of other larger applications do. So per data source, you just have your pretty traditional write your own backup strategy, and then reinstall that during the post upgrade hook. And then back up to some secure or hopefully duplicated store. So that is the current answer. But if you look at the SDK roadmap, great plug and action item. If you go to the forums, I've shared out the roadmap for the SDK team, and one of the features that we are going to be addressing in the nearer term is adding in support for downloading an entire canister along with all of its data for the purposes of backups, and also to run upgrades locally so that you can make sure that you're going to have a safe upgrade when you do the same thing in production. So that is a near-term feature that we're going to be prioritizing, and I'm super excited for, because the safe upgrades has been a relatively scary story, and we didn't have a definite answer for people. So safe upgrades is like the narrative of where SDK is going to be focusing our efforts for a while.
Kyle, the next question in Q&A is interesting from Austin. So just how many places does the FBI have to raid to shut it down? I'm assuming from like a data center perspective.
Yeah, I don't know exactly how many it would have to raid to shut it down. But if they raided like a couple, it could become pretty problematic. Like any given location isn't going to host multiple nodes of a single canister. So there still is enough for consensus. I think we have like 11 nodes is the default distribution now. So if you rated like a majority of those, a canister could actually be like lost and consensus would no longer be reachable. That would be a pretty dramatic operation. But even just taking a single node or a bunch of node providers offline would become a really big pain from a DevOps perspective of getting everything back. But like any data center could like, be wiped out or go offline in a natural disaster, and that wouldn't threaten the network. So it wouldn't be fun. We'd have a lot of like rebuilding and setting stuff back up. But the network isn't threatened by any single location. But that said, this is relating to like the whole intellectual property discussion. And I think that there are a lot of big questions that we need to answer about, where does the ownership of, how do we interface with governments? What is the level that ideally someone should, like a government should be able to reach out to in the cases where governments do like to interact with people who provide internet services. And I don't think that node providers is ideally where we'd like people going. So hopefully we can continue working on that and come up with systems such that node providers don't have the FBI knocking on doors.
Cool. Thank you, Kyle. And the final question we see here, is there any collaboration with big companies to use the internet computer? Actually, there are some things in the works. I don't think that we have announced them yet. So Kyle knows what I'm talking about. So can't do a full alpha leak, but there are some really exciting collaborations in the pipeline with major tech companies, but I think all of that will be announced soon. So stay tuned for more.
Yeah, and I will say that if you were to go to contentauthenticity.org and do your own research, you might find Dfinity inside of that group.
Literally,
and draw your own conclusions. But yeah, we've got some work that we're in progress on, and would really love to ramp up the overall partnerships and start getting some of these bigger names to start using the internet computer for various purposes. And there's all kinds of growth opportunities that the internet computer is a great platform for.
Love that, Kyle. Love that. Just a little bit of a teaser. Cool. I think that is all of the questions for today, and we're just coming up on time. So again, thank you to Kyle for leading such a wonderful discussion. Thank you to the audience for your great questions as always, and see you next week for our next community conversations. Bye, everyone.